Hello, good morning and good afternoon. So if you're watching this video, then that means you probably understood our lesson on solving absolute value equations and you're feeling ready to move on a little bit. So I'm going to be walking you through several of these problems on this page, and then after the first 20-30 minutes of class or so, then I'm going to switch groups and come work with you and help you out on anything that you might still have questions about. So the first problem I want to do is number 9. And there's a reason I'm starting right there. I'm not at number 1, which you'll see in a little while. Okay, so number 9. Now, when you're solving an absolute value inequality, it's essentially the same thing as with an equation, but there's an extra something that you're going to have to keep in mind. So when you start out, you're still going to be using order of operations or PEMDAS in reverse. Okay, so first thing I want to do is add or subtract anything outside the absolute value. So in this case, I have a minus 6. So to cancel that out, I'm going to add 6 to both sides. Okay, so absolute value of 4n is greater than 32. Now, I've done that. I don't see anything to multiply or divide that's outside the absolute value, so I don't have to do that either. There's no exponents in sight anywhere. And now we're at our parenthesis or grouping symbol step. And if you recall from yesterday, that means you need to split your absolute value inequality, in this case, into 2. And again, that is the step that kids tend to forget. Behave yourself, camera. There we go. Kids tend to forget that step, so please don't forget that step. All right, so I'm going to split this. So just as yesterday, you have 4n, and it's greater than 32. Now for this one, when you put the negative, you need to flip your inequality sign. So, and you want to kind of think back to Algebra 1. When you first learned to solve inequalities, remember that when you multiply or divide by a negative number, the sign flips because your negatives and your positives are mirror images. So if you're greater than on one side, then the mirror image is less than on the other side, on the negative side. Okay, so that right there. Remember to flip your sign. Oh my gosh. Don't forget. And the last thing we need to do, we are inside the grouping symbol or the parentheses, divide by 4. So n is greater than 8. And n is less than negative 8. Actually, that's more. Okay, so I'm going to have you go ahead and plot this on a number line. Okay, just do it one at a time. Greater than without the equal to part is represented by an open circle. So that's probably something that you learned about in Algebra 1, but I know it's been a while for some of you. And if n is greater than 8, then we want to show, well, n could be 8.5, that's greater than 8. N could be 9, n could be 12, whatever. So shade that direction and then kind of shade the arrow in. Or n could be less than negative 8. And there you can see the mirror image I was talking about. That's why we need to flip the sign. Because if it's greater than 8 over here, then in order to mirror properly, it's going to have to be less than negative 8 on this side. Okay, so again, don't forget to flip your sign. Don't forget. All right, so pause that if you need to in order to finish writing or to kind of take that all in. And let's look at 14. Okay, so I'm going to go to 14. All right, so not much different than the last one yet. Still want to use order of operations in reverse. The camera will behave itself. There you go. Okay. All right, do we have anything to add or subtract outside the grouping symbol or the absolute value? No. Do we have anything to multiply or divide? Yes. So I'll divide by 7. So then I've got the absolute value of v minus 4 is less than 4. So that's done. No exponents in sight. Now I can go inside the grouping symbol, which means, again, split. I've got v minus 4 is less than 4. So just like yesterday, that first one doesn't really change. So this stays the same, this number stays the same. And the other one, v minus 4. And think to yourself, what do I have to do to the symbol? Flip it. And then this is negative. Okay? So again, don't forget. Don't forget to do that. Okay, and then plus 4 on both sides. So v is less than 8. And v is greater than 0. Now in this case, you'll notice and. So v is greater than 0, he's 0. And again, I'm using an open circle because I do not have an equal to right here. And v is less than 8, there's 8. In this case, if v is greater than 0, but less than 8, you just kind of want to shade in between. That means that any of these shaded numbers between 0 and 8, but not including 8, will make this true. So for instance, let me just pick one to show you. 6. 6 is in the shaded part. So if you imagine putting a 6 in for v, 6 minus 4 is 2. The absolute value of 2 is still 2. And 7 times 2 is 14, which is indeed less than 28. So it works. Okay, so again, pause that if you need to, and then we're going to move on. And I want to show you number 4. Okay, number 4. There's a reason I didn't do this right away. There's something else you got to remember back from Algebra 1 when you first learned about inequalities. But first, we're just going to start as usual. We are solving, so we are doing order of operations in reverse. And I want to start by adding or subtracting anything that is outside the absolute value. And there's nothing, because that's multiplication. Just cross it out. Okay, and I can cancel out that times -7 by dividing by -7. So I have absolute value of v minus 10. Okay, now here's where you got to recall Algebra 1. And think about when you multiply or divide by a negative number in an inequality, the sign has to flip. So that might be something you kind of forgot about if you haven't used it in a couple of years. But since I'm dividing by a negative, I've got to turn my inequality around. And that's again because positives and negatives are mirror images of each other. So if one side of an equation starts out negative and becomes positive, then for this rule to still be true, you got to flip the inequality. Otherwise, the mirror image doesn't mirror. Okay, so I did that. I don't have to do that. And now I'm inside the parentheses. So I'm going to split it. So v minus 10 is greater than or equal to 3. V minus 10, and oh, what do we have to do here? What did I tell you not to forget? That's right, flip the symbol before you make that negative. Again, it's a mirror image thing, okay, for the negatives and positives. So our last step is going to be to add 10 to both sides. So I have v is greater than or equal to 13, and v is less than or equal to 7. And there's my solutions. Okay, and that's an OR solution because as you'll see, they're not going to overlap. So v is greater than or equal to 13. Since I've got the equal to, I'm going to go ahead and use a solid dot on that. And v can be greater than 13 as well. So I'm going to shade the greater numbers. And then v could be less than or equal to 7. So since it can equal 7, I'm going to put a solid dot. And for less than 7, I'm going to shade the numbers lower than 7. Okay, so pause that if you need to. And then we're going to look at some special cases. The ones that, if you catch it, are the shortest problems that you can do. Okay, so 1 and 2. Number 1 first. So at first glance, you might catch on to the fact that we've got this negative number here, which yesterday meant no solution. Today, that might mean no solution, or it might mean something else. And I'm going to show you. So start out, PEMDAS in reverse. Anything to add or subtract? Nope. Anything to multiply or divide? Yep, divide by 4. Okay. So right now I've got absolute value is greater than -1. Now remember, absolute value is the distance. Distances are positive. So we know that this right here, this absolute value is positive. And what this is essentially asking us is, what positive numbers could give this a value greater than -1? Well, all positive numbers are greater than -1 because they're positive. So this is always true. Positive numbers are always greater than -1. So our solution to this is x can be any real number. Okay, because no matter what I put here, when I take the absolute value of this, it's going to turn out positive. And positive numbers are always greater than -1 because -1 is a negative number. So no matter what I pick for x, it's going to be true. So my solution is all real numbers. And in that case, I'm just going to shade the whole number line. Whee! Okay, so kind of keep this in mind. That will save you some work sometimes. Okay. Number 2. Once again, you're probably seeing a negative number. But check out the signs flip the other way. So hopefully that's telling you, I think this problem is going to be different. But let's see how different. So start off with PEMDAS in reverse. Any addition or subtraction to cancel? Well, not outside the absolute value, so don't touch the 5, leave it alone. Anything to multiply or divide? Yep. Can multiply by 4 to cancel that out. So I have absolute value of v plus 5 is less than or equal to -8. And since I multiplied by a positive, I can leave the sign alone. I don't have to flip it or anything. And there's no exponents. And now, wait a minute. Didn't we just say this is always positive? Absolute values always come out positive. Can a positive number ever be equal to -8? Well, no, because positive numbers are positive, -8 is negative. Okay. And a positive number also cannot be less than -8. -8 would be out here somewhere. Okay, that if you're less than -8, you're a negative number. Okay, so a positive number can never be less than or equal to a negative. So in this case, since this is impossible, that can't happen. Our answer is no solution. And again, you can write out the phrase no solution. You can use this. You can also use the empty set, like that. Okay, so I would like you to find a partner if you want. Try some more of these. And hopefully in a couple of minutes, I will be able to switch groups and come check on any questions you might have.